Welcome to a slow, beginner-friendly lesson on query parameters and headers in Python, made for absolute beginners. Parameters and headers begin. Today we open a skill that unlocks almost every modern web service, passing extra information with your HTTP call. Until now you called a URL and accepted whatever came back. Real services need more. You need to send a search term, a page number, a sort order, an access token. Python's requests library gives you two clean ways to attach this extra information: query parameters and headers. By the end you will shape your requests like a pro. 2 channels, 1 skill. Before we start, a quick recap. In the previous lessons you learned that requests.get of a URL makes an HTTP call. The response has a status code, 200 means success. The response has a JSON method that parses the body into Python. Today we add a new skill, sending extra information along with your call. Services use this information to filter results, identify you, or authorize the request. 2 channels carry that information, parameters and headers. Today adds extra information. Until now your request was a single, plain call. You asked for a URL, you got a response. That is enough for static pages. But real services are conversational. They ask, what do you want? Who are you? How many results? Today your request learns to carry details. Plain calls are not enough. Look at a real URL. It starts with the scheme, HTTPS. Then the host, api.example.com. Then the path, users. After the question mark comes the query string, name equals Ada, ampersand, age equals 36. The query string carries small pieces of information that shape the response. The host and path say where. The query string says what you want. Know the parts. The query string is a list of key value pairs. Each pair is key equals value. Pairs are joined by the ampersand character. Each pair adds a filter or instruction. Name equals Ada, only users named Ada. Age equals 36, only that age. Active equals true, only active records. The service reads these pairs and decides what to send back. Order does not matter. Each pair is independent. Pairs joined by ampersand. There is a catch. URLs only allow a small set of characters safely. Letters, digits, dashes, underscores, fine. But a space, a quote, an ampersand, a non-English letter, those need to be encoded. Encoding replaces the unsafe character with a percent sign followed by 2 hex digits. Space becomes %20. An ampersand inside a value becomes %26. Writing these by hand is painful and error-prone. Good news, Requests does this encoding for you automatically. Encoding keeps URLs safe. Hold this picture in your mind. Every URL splits into clear parts. The scheme says how to connect. The host says which server. The path says which resource. The query string, after the question mark, sends small key value details to that resource. When you build requests in Python, you do not paste these parts by hand. You give requests the base URL and a dictionary of parameters. The library assembles the correct URL for you. Hold the parts clearly. Here is the wrong way. You might be tempted to glue strings together, base URL plus question mark plus name equals plus the value. This breaks immediately. The value Ada Lovelace contains a space. The space is not allowed in a URL. The server will misread the request or reject it. String concatenation also breaks when the value has an ampersand or a quote. Never build query strings by hand. There is a better way. Never glue strings. Here is the right way. Pass a dictionary to the params argument. Requests takes the base URL, adds the question mark, encodes each value safely, and joins pairs with ampersands. The space in Ada Lovelace becomes plus or %20, both valid. Print response.url and you see the full, correctly encoded address. This is the cleanest way to send query parameters. Hand requests a dict, let it do the work. Let requests build it. Multiple parameters? Just add more keys. Search equals Python tutorial, note the space, requests will encode it. Page equals 2, requests converts the integer to a string for you. Per page equals 20. Sort equals newest. Requests builds the full query string from this dictionary. You write Python values, requests handles the URL syntax. This scales, 10 filters is as easy as 1. More keys, same shape. Parameters are 1 channel. There is a second channel called headers. Parameters travel in the URL, visible to anyone watching. Headers travel inside the request envelope, separated from the resource path. Some information belongs in parameters. Some belongs in headers. Today you learned both. 2 channels now. Now meet headers. A header is a piece of metadata about the request. It does not appear in the URL. It travels inside the request envelope. Common headers include authorization, who you are. Content type, what kind of data you are sending. Accept, what kind of data you want back. You send headers as a dictionary, just like parameters, but with the headers argument instead. Metadata, not in the URL. Here is how to send headers. Build a dictionary where each key is a header name and each value is the header content. Accept equals application/JSON tells the service you want JSON back. User agent identifies your script, many services require this. Pass the dictionary to the headers argument. Requests attaches each header to the request. The server reads them and responds accordingly. A dictionary of headers. The most common header you will send is authorization. Many services use bearer token authentication. You receive a token, a long string, when you sign up or log in. You send it in the authorization header, prefixed with the word bearer and a space. The service checks the token and either grants access or returns a 401 or 403 status. Never hard code real tokens in shared code, use environment variables. Bearer means carry the token. Content type is another important header. It tells the service what kind of data you are sending in the request body. For modern web services, that is usually application/JSON. When you call requests.post with the JSON argument, request serializes your dictionary to JSON and sets content type for you. Sending headers explicitly is useful when the service expects something specific. Tell the server what you send. Many services use API keys instead of full tokens. An API key is a simple secret string that identifies your account. Services accept the key in two common places. Some want it as a query parameter, $API key equals your key. Some want it in a header, often authorization or a custom header like x-API-key. Always read the service documentation. Sending the key in the wrong place means a failed request. Keys identify you. Here is the query parameter style. The API key sits alongside your other parameters in the params dictionary. The service reads it from the URL. This style is simple, but the key is visible in the URL, in browser history, in server logs, in the response.url field. Use it only when the service requires it. For new services, the header style is preferred because the key stays out of the URL. Visible in the URL. Here is the header style, preferred by modern services. Your key lives in an environment variable, read with os.environ.get. The key goes into a custom header, often x-API-key. Your params dictionary holds only the real parameters. The key never touches the URL. This is cleaner and safer. Combine both, params and headers, in the same call when the service requires both. Cleaner and safer. Hold the picture. Parameters shape what you ask for. Headers carry your identity and preferences. Together they let you call real services, search engines, whether APIs, your company's internal tools. The skill you build here applies to almost every web API in the world. The key opens the door. A debugging tip. Whenever your parameters seem wrong, print response.url. It shows the full, encoded URL that requests actually sent. You can paste it into a browser and compare. You will see how the space was encoded, how the integer became a string, how the ampersands joined the pairs. This single line of debugging saves hours of confusion. Always know what URL you actually sent. Debug with one print. Let us put it together with a realistic example. You call a book service. Params carries a search term, Python for beginners, with that space, a limit of 5 results, and a language filter. Headers asks for JSON. If the status is 200, you parse the body and print how many books came back. Notice how clean this reads. One call, one dictionary of parameters, one dictionary of headers. That is the shape of every real API call. A realistic call. Many services split large result sets into pages. You walk through them by changing the page parameter in a loop. Here we fetch pages 1, 2, and 3, 10 books each. Each iteration builds a new request with a different page value. Requests handles the URL encoding every time. This pattern, loop, change a parameter, call again, powers everything from scraping search results to downloading large datasets. Walk the pages. Take this lesson in one breath. Query parameters shape what you ask for, filters, search terms, page numbers. Headers carry metadata about the request, authorization, content type, user agent. You send parameters with the params argument and headers with the headers argument. Both are dictionaries. Never build a query string by hand. Let requests encode values safely and assemble the URL correctly. 2 channels, 1 habit. What comes next? Every skill you learn today assumes the call succeeds. Real networks fail. Connections drop. Servers return errors. Tokens expire. The next lesson is error handling, how to check status codes properly, how to use raise for status, how to wrap your calls in try and accept, how to set timeouts so a slow server does not freeze your script, and how to retry safely. Robust code is the next skill. Failure is next. Quick self-check. Can you write a call with 3 query parameters? Can you add an authorization header? Can you print the final URL to debug? Can you explain in one sentence why building a query string by hand is dangerous? If any feels shaky, rewatch the matching part. The next lesson builds directly on this one. You will need params and headers comfortable before we add error handling. Say each out loud. For practice, call bin.org/get. It echoes back everything you sent. Pass 2 parameters and 1 custom header. The JSON response includes an args field with your parameters and a headers field with your headers. You will see exactly what the server received. This is the safest place to practice. No real service, no real key, just an honest mirror. Play until params and headers feel natural. Practice safely. Thanks for learning parameters and headers. Next we handle errors gracefully. Robust calls come next.